And friends, welcome to my YouTube channels. My YouTube channel is Dr. Ashok Ji Mac Solution. Today I am going to discuss the conduction's heat transfer concept for the spherical body. So how to remember the formula and how to attempt the problems and how to solve the problems. Before two video I given for plane wall, cylindrical body. Now this is spherical body. So only thermal resistance, if you are remember, if you are understand, you can solve the any type of big problems also in simple steps. So now here see, I will explain little how this conduction heat transfer for the spherical body coming. So already you know first 4 years law of heat conductance minus Ka dt by dx. Dx na plane wall. So spherical wall is there dr, because if you take the small strip, small thickness will be dr. Now area will be here, what is 4 pi r square spherical body. That only cylindrical what we did 2 pi rl we changed. Now we'll substitute and we'll integrate. Q is equal to minus k 4 pi r square dt by dr. Now we'll separate the variables. Q dr by r square is equal to minus 4 pi k dt. T1 to T2. Here integrate R1 to R2. Upper limit, lower limit. Lower limit, upper limit, lower limit T1, T2. 4 pi k r separate. So we'll integrate. What is 1 by r square integration minus 1 by r. If we'll apply the limit r1 to r2, so it will come minus 1 by r2 minus 1 by r1. Take the minus inside, so what will come? 1 by r1 minus 1 by r2. This will come. If we'll take the LCM r1 r2, so r2 minus r1 will come. So finally what will come? This side I'll write r2 minus r1 by r1 into r2. So after the integration and applying the limit, what will come? Q r2 minus r1 by r1 r2. So this integration dr minus 1 by r, upper limit lower limit apply, upper limit minus lower limit, minus taken out, minus multiply, this will come negative, this will come positive. So this way take the LCM r1 r2. So this came. Now you will here T2 minus T1 will come. Okay, we'll write one more steps. Minus will be there 4 pi k T2 minus T1. 4 pi k T2 minus T1. Now this I will write it. Now what is the thermal resistance we'll write here. So this will like T1 minus T2, now this will become plus. So Q is equal to finally what is coming? 4 pi T1 minus T2, that due to the negative sign interchange. Now what is the here? It will come denominator R2 minus R1 by R1 R2. This K will come here. So K. What is this one? Thermal resistance. Thermal resistance for the spherical body. If one spherical body will be there, what is the formula here coming? 4 pi T1 minus T2 R2 minus R1 K R1 R2. R2 minus this I wrote convective heat transfer for the single block. Now convection heat transfer. So A, what is A here? 4 pi R square. 4 pi will be there, R will come down. So convective thermal resistance for the spherical body 1 by H into R square. H is heat transfer coefficient. So these two you have to remember. Thermal resistance for conductance for the spherical body, thermal resistance for convections, thermal resistance for the single body. If two body will be there, now look here, general terms, how to remember. Two block will be there, overall temperature what is T1 minus T3. This also T1 minus T2, first temperature, last temperature. Here two spherical wall is there, spherical there, T1 minus T3. Then what is thermal resistance for 1? R2 minus R1, K1, R1, R2. Second, R3 minus R2, R2, R3, K2. Suppose one more sphere will be there. R4 minus R3 divided by R3, R2, R3, R4, K3. Like this general terms will come. How many blocks will be there? Just to add. So what you are observing here, if you know the one, second add, third again add, only symbols will be changed, R3, R4, R2, R4, whatever notations will come. Now look, if conduction and convection both will be there, thin film will be there, inner and outer. So what you have to add? 1 by h r square. So first inside na h a r1 square. Last what is third is na r3 square hb. Remaining middle will be, things will be same. Remaining will be, see, thermal resistance for the sphere body 1, thermal resistance sphere body for 2, just you write. This is the trick for the plane wall, cylindrical body and spherical body. So if you know the thermal resistance for the individual body and convective heat transfer thermal resistance for the individual body, you can add, suppose conduction, convection both, just add both side. Inside just write thermal resistance for the spherical body 1, 2, similarly like this. Okay, students, thank you. Watch this video and subscribe the channels. Okay.